Hey there, this is Christian, and you're welcome back to the DonHub channel. So, today we are diving deeper into the exciting world of machine learning. In our previous video, we explored the fundamentals of machine learning and AI. We looked at data and how we can pre process it. But now it's time to take our journey to the next level. So, what is on our agenda today? Well, today we are venturing into the realm of supervised learning algorithms. These are the backbones of machine learning applications, allowing us to make predictions, classify data, and uncover insights from our data sets. Today, we are going to unpack some of the most fundamental supervised learning techniques, from regression analysis to classification algorithms. By the end of this video, you will have a solid understanding on how these algorithms work and how to get started with implementing them in your own project. So grab your favorite drink, get comfortable, and let's embark on this exciting journey together. All right, so let's start. So the first one we are going to talk about is regression analysis. Regression analysis is a powerful technique for predicting continuous outcome variables. Okay, so the outcome could be a single base variable or a multiple base variable, and this outcome is supposed to be a continuous variable, which is a numerical data. Okay, and it helps us to know the relationship between our input and then our target variable, which is our independent and then our dependent variable. Okay, so your features and then your labels. It helps us to know the relationship between that the two. Okay, and then we have some types. The first one we will talk about is linear regression. Okay, so with linear regression, simply the relationship between the dependent variable and then the independent is a linear relationship. Okay, so when it's linear, then it's a linear regression. Okay, and we have some types or categories under them, and the first one is simple linear regression. So with simple linear regression, we have a single independent variable mapping to a single dependent variable. That is when we have simple linear regression. Okay. With multiple linear regression, we have multiple independent variables, which is multiple inputs mapping or giving you a single output, which is single dependent variable. We also have multivariate linear regression. With this one, we have multiple independent variable mapping to multiple dependent variables. So you give it multiple inputs and it gives you multiple outputs. Okay, so that is linear for linear regression. Now let's move on to polynomial regression. So with this one, the relationship between the dependent variable and independent variable is not linear. Okay, so it's to the degree of power n. Okay, nth term, which could be power 2, 3, 4, and above. Okay, we also have logistic regression for predicting categorical variables or values. We also have support vector regression, which takes the idea or the principles from support vector machine and uses it to solve regression problems. Okay. Now the next one we will talk about is classification algorithms. Okay. So with regression algorithms, the output is a continuous data. Okay. But with regression algorithm, the output is a categorical. Okay, which that is the output is being categorized or being added to a certain group of categories. Okay, so that is when we use the categorical algorithm. And we have some types, or let me say, forms. Okay, we have binary classifier. With this one, the possible outcomes are two. Okay, it's either yes or no, on or off, minus one or one, zero or one. So no matter what, the output should be, the possible outcome should be two. That is when we use the binary classifier. Okay. We also have multi-class classifier. With this one, the possible outcome is more than two. Okay. So let's say a web page can be designed to talk about sports or talk about politics or entertainment or education. Okay. And it can't talk about the two. It has to belong to one of them. Okay. So that is when we use multi-class classifier. All right. So now with multi-label classification, as I stated here, so S can potentially belongs to several categories. Okay. So a web page can be designed to talk about sports and at the same time talk about entertainment. Okay. So that is when we use the multi-label classification or classifier. Now let's move on to some types. Okay. We have for linear models, we have logistic regression. Okay. We have support vector machine, which uses the hyperplane separator to separate data sets. Okay. So that and then it creates some boundaries. And then based on that, you can categorize an input into any of these categories. Okay. And we also have nonlinear models. For nonlinear models, we can use either k nearest neighbor, we can use kernel support vector machine, we can use naive Bayes, we can use decision tree classification, which uses decisions or it uses training data to create trees. Okay, and based on that, it can use those trees or the branches of the trees to make predictions. We also have random forest classifications as well. And we can evaluate these algorithms using either log loss or cross entropy loss, which measures the classification model's performance. We can also use confusion metrics to visualize the performance with the help of true positive, true negative, false positive, false negative. Okay. We can also measure the ability or the classifier's ability to distinguish between two classes using ACU, which is area under the curve, ROC. Okay. And moving forward, that is in our next video, we are going to implement some of these algorithms. And the first one we are going to implement is logistic regression. Okay, so we are going to predict categorical dependent variable using independent variables. Okay, so the independent variables are features and our output, which is the label, is a dependent variable. Okay, and we also have k nearest neighbor, which is a lazy classifier. We are also going to use that, or we are going to implement our model with that. We're also going to implement support vector machine model. We use that one to also solve classification problems. And naive Bayes, which is also a simple but yet effective. So we are going to implement all these algorithms in our coming videos. Okay. For this implementation, we will need data sets and some kind of steps. Okay. So stay tuned for future videos where we will explore these algorithms with real data sets and then code examples. Okay. Kindly click on the subscribe button if you haven't liked this video, share with friends, and stay tuned for the next video. See you another time.